All right, in this module, we're going to start looking at developing our own data types. So far, we've used only built-in data types, basic data types, and also some complex ones like lists and dictionaries to model our data. So we're kind of using what Python provides us. Now we're going to start to develop our own structures, and we'll use this as yet another tool in conjunction with functions to help us organize our code a little bit better and get a hold of or get a handle on the complexity. So, like I said, we've seen a number of different data types. So, Boolean, int, float, those are all basic scalar data types. We've seen strings, tuples, lists, dictionaries. There's something a little unique about the ones that are listed in green here, and tuples would be included as well, in that they encapsulate some complex data and some operations. So a string, it seems basic, but really it's a sequence of characters. And if you recall, we've got functions associated with strings. So we can call the find method, we can call the split method, and we've got all sorts of functionality built in to a variable of type string. It's not just data, it's got some operations associated with it. List was the same way. We had append, we had operators like in to be able to search through the list. We can sort a list. All of that stuff is again sort of encapsulated within a particular piece of data whose type is list. The dictionary data structure is actually much more complicated than just the sequence, right? In fact, under the hood, and we'll see later on, it's actually a hash table. There's a fair amount of complexity that goes into structuring the relationship between keys and values, and then allowing us to find a value with a very efficient way of finding a value based on a key. So there's a lot of hidden stuff going on behind the scenes in the dictionary object that we're not really aware of, but we reap the benefits of consistently. And again, this is just sort of carrying off of what I was just saying, the dictionary, the non-scalar data structure. Not only does it provide efficient lookup, it also has additional methods, such as the keys method that returns all the keys associated with that particular data structure. So again, methods, functionality, and also structure underneath the hood in these individual objects. So dictionaries and lists actually are very powerful, and you can write a lot of Python code without actually going much further than using just simple dictionaries and lists. They're enormously flexible. But every once in a while, we're going to want something to represent something very specific to our programs. And in these cases, we're gonna go beyond what Python provides us and start building our own data structures, and we'll call those classes. So a class is a new data type that you as a user, you as a programmer, create, define, and then can use throughout your program. And in these new data types, you can define the structure, right? So it's not just a single value contained in that data structure. It can be any number of things. And you can define the functions or the methods that a user of your class or a user of your data type, probably you, can invoke and can work with. So classes offer a really great way to organize the logic of our program and allow us to take advantage of things like decomposition and abstraction even further beyond what we can do through the use of functions. So classes in Python. In order to define a new data type, a new class, first off, we're going to give it a name. And the naming conventions for classes are the same, or the naming rules for classes are the same as variables and the same as functions. So class names can't have spaces, they can't start with numbers. We should be deciding what data the individual class will hold. So we might, remember, a class is a data type, and we might have many instances of that data type. Just like we can have many dictionaries in our program, we can have many lists, we can have many instances of the particular class that we're going to create. Each one of those instances will have data associated inside of it. It might have a couple of integers. It might have a list inside of it. It could have a string inside of it. It could have all three. And each instance will have that data unto itself. We're going to decide how an instance will be created or initialized. We're actually going to create sort of like a factory method that builds our class and initializes it properly so it can begin to be used. And we're going to decide what methods or functions that it should be able to support. So for instance, the string class or the string object in Python has a substring function. It has a find function. It has a split function. The list has an append function. It has a sort function. Well, we're going to define functions for our new data types as well. So I'm going to walk through a very basic yet pretty illustrative example. Let's say we want to implement in our program, for whatever reason, a set of integers. And I'm going to emphasize set in that it's different than a list. A list is an ordered sequence of values, and one of the key differences between a set and a list is that a list can have duplicate values in it, and a set, from a mathematical perspective, does not have duplicates. Right, so it's a little unique. It's different than a standard list. So what we can do is we can start to create a new data type called inset. All right, so down here is sort of just comments here, but we're going to start with the keyword class followed by the name of our class, and then a colon. So we're going to it's the same beginning syntax of a block of code, but now instead of def for a function or for a loop or something like that, or try or except, now we have class. All right, and we're going to define methods, the initialization, general methods that belong inside of our class within this block. All right, so the first part, all right, the first method that you're going to want to create underneath this block of code for your class is a way to initialize, a way to create a new instance of your object or of your class. So if you remember, you could, with lists, we could take a variable and set it equal to list open and close parentheses or dictionary open and close parentheses. And that was a way of generating a new object. And so the same thing follows here. We can create an instance of our int set simply by using the class name followed by open and close parentheses. Now that open and close parentheses can have parameters in it, and we'll see that as we go, a way of creating custom factory methods. They're called also constructors. All right, so what's this all about up here? So we've created a function, and aside from the fact that there's two underscores at the beginning and end of this word, I want you to point out that this looks exactly like a regular function definition. All right, so you've got def, you've got a name of a function, and you've got a parameter, and I'll talk about exactly what self means in a moment. The name of the function looks a little strange, and it looks strange on purpose. It's a special reserved name for a function that is called whenever we instantiate a variable of a particular type. So every one of the classes that you create should have an init function. The init function you never call directly. It gets called implicitly when someone generates or creates an instance of your class using that standard syntax when they call your class name. So when we say int set open and close parentheses, automatically we will call the init function. So what's the parameter all about? All right, so notice that we don't have a parameter being passed into these parentheses, but we do have this self parameter inside the init. All methods associated with an object have an implied parameter. All right, so it's an automatic parameter. It's the first parameter in the function. In this case, it's the only one, but it doesn't need to be. We can have more parameters. It's implied to be the first one. It refers to the actual instance, the actual piece of data, the actual variable that this method is being called on. So if you think back again to like list.sort, right? We can have three different lists. We can have list1.sort, list2.sort, list3.sort. And the sorting code, of course, when that gets executed, it works on the right list, right? If you call list2.sort, it doesn't sort list1, it sorts list2. And there has to be a way for that function to know which piece of data to actually act upon. Well, that's what's happening here as well. The self parameter is automatically provided for us so we can refer to the right piece of data. So it's automatically set to the instance that we're calling this on. And so what we're saying here is that, all right, we've got an object called self, and I'm going to create a vals attribute. This is going to be the list that corresponds to the data in my set. And essentially what I'm going to do is my inset is a wrapper around a list, and it just makes sure that the user never puts multiple things in the list, or multiple duplicates in the list. So if I create set1 equals inset and set2 equals inset, what's important to understand is that this init function is called twice. It's called for each time we create one of these instances, and self is different. It refers to a different object each time it's called. Right? So each of these insets gets its own vals list. It's an empty list when it's initialized. So in memory, we're going to really see we've got two objects, set1 and set2. They've each got their own vals list, again, starting off empty. Okay, a little vocabulary, because I've been using some things interchangeably. First of all, when we all know what functions are, I'm starting to use the word method a lot. And in Python and in many languages, we differentiate between functions that are standalone and functions that are associated directly with a class by using the word method. So a function that is associated with a class, generally I'll call them methods. On a class, we could also call it a method attribute. Sometimes you'll hear people say that as well. An attribute, whether it's a method or a data attribute, it refers to something that is part of an object. All right, and an object, by the way, is an instance of a class. Right? So when I say object, I mean a variable that is an instance of a particular class. Variables that are inside objects, so that vals list, that's a variable that's attached to that self object. Those are typically called properties rather than variables, or attributes rather than variables. And again, it's not that they behave significantly differently. It's just a way to differentiate it when we're talking about these things. So when somebody says function, they generally mean top level kind of global function, standalone function. When somebody says method, chances are they're talking about something associated with a class. And the same thing with variables versus properties. Variables tend to be standalone. Properties are variables inside of a class. All right, so we've got our init function, and that's certainly required. And its job is to create an empty list just to initialize the current instance. But we can also have our own methods, right? So I'm defining now a new function called insert. Right? So insert is going to be customized logic because it's not the same as appending to a list. We only want to append to our list inside of our inset if the value doesn't already exist in the list. So I've got two parameters. First off, I've got self. So again, every method that's inside of our class is going to accept as its first parameter always self. Right? And this is going to be automatically filled in by Python. We won't actually use this value or this parameter when we call the functions ourselves. We're sort of using it implicitly, and you'll see that in a second. The second parameter is the item that I want to add to the inset. Here's my custom logic. If the item's not in self vals, add it. Right? And again, you need to use self.vals rather than just vals because this is associated with a specific object called self. So when we use this, and here's where the self business I think starts to make a little bit more sense. When we say set.insert, remember list.sort, same idea, same syntax with this dot operator. When we say set.insert, the left-hand side of the dot operator is automatically being set in and passed in as self. So if I had set1 and set2, we would pass in the right one. So insert 5, insert 6 is going to insert 5 and 6 into the vals list of self. So here's an example of where we have two of them, right? So we've got set 1 equals inset, set 2 equals inset. If I insert 5 and 6 to set 1, when I call insert, remember the insert function has a self and an item. Set 1 will be self in the first two calls, and set 2 will be self in the third call. And we'll end up with two sets, right, with vals of 5 and 6 and with vals of 7. So they are distinct, right? So we can have many, many insets. Each one of them has a distinct list, and we can call methods on them by using the dot operator. So I want to point out something that you might already be thinking about. It's easy to start to say, well, gee, why do I need to learn all this extra syntax? I certainly could have just implemented a set using a list without a class. I could have had my main part of my program declare a list, and anytime I wanted to add something to the list, I could just check and say, okay, well, if it's not in the list, don't add it. And that's a reasonable point. We probably could get away with never writing classes in a Python program, but the problem is that it's the same issue as a function. It's the same issue as, well, why don't we want to repeat the Newton-Raphson method every single time we want to do a square root? Everything would be great because we'd never have to learn how to use functions. That's true, but you'd be repeating the same code over and over and over and over again. And your program would just be growing and growing and growing in complexity. The value of a class is that it is responsible for the state of its own data. So we don't have to think every time we use the inset class throughout our or every time we use the set throughout our program. We don't have to think and go through the exercise of making sure that we do the check to see whether or not there's duplicates in the set. We can use the set object like it's a built-in part of the language, and we can just say add this, insert. And inside the set, we'll take care of the business of making sure there's no duplication. Right? It's reusability, it's abstraction. It's the same concept as functions. The class ensures the data is consistent with the rules associated with the class. Right? The class is responsible for making sure that there's no duplicates, not the programmer who's using the set, not you in your main program who's using 16 different sets in 400 lines of code. Right? You're not responsible for it. The only part that's responsible is the small part of code inside the class code. The book calls this idea of making sure that the data is consistent. It calls this the representation invariant, the part of the data representation that always must hold. Right? And it's kind of a complicated way of saying what I'm talking about here in terms of ensuring that the data is consistent with the rules that we've set out to provide. In addition, we've got we can put any number of methods into this, right? So the set might have an insert. It could have a lot of different things. And in the following modules, as we add on to this, we'll see some other uses of some different functions. That said, there are some method names that we can't use, or that are at least reserved for very special use. So we have the init function that we've seen before. We also have a string function, and again, these are two underscores, not one. The string function, and again, the first parameter and really the only parameter of the string function would be self. We can create that function, and Python will automatically call that function whenever it wants a string version, a string representing my object. So for the set, for instance, I might create a string consisting of all the data in my set, and actually this is based off an example in the textbook, and you can look at that example in chapter 8, I believe. So these are actually called these methods with the double underscore. They're called magic methods because they get called somewhat magically. You don't actually ever directly call them. So the init function is not directly called. It's called automatically when you create an instance of an object. The string method is not called explicitly, although you can call it. Instead, like when you do something like print and you give a variable of type set, Python will automatically call the string function on it if it's there. There's actually quite a great deal of these magic methods, and we'll get a chance to look at these more and more over the course of the semester or over this course. There's a special compare function, an equal function that should return true or false whether or not self is equal to other, another instance of the set. So for instance, right here, we might, inside this function, we might check to see whether, well, maybe every integer in self is also in other, and maybe that they're the same length. We can do less than or equal to, greater than or equal to. And the value of all of these is that whenever we have an algorithm that's using the less than, greater than comparison operators, Python will automatically call these functions with our classes. So we can actually compare sets. We can check to see whether sets are equal by using the double equal sign or using the less than sign. And it's a way of sort of having this automatic behavior built in for your class using the standard operators. There are many more. It's well beyond the scope of this class. You can certainly look online. There's a number of resources. I've left you one resource here. We're gonna be talking about classes a lot over the course of the next few modules. So we're gonna go into more depth. But right now, the big takeaway from this module is understanding how classes can allow us to structure our data and our methods. So we can invent new data types now that have our own methods attached to them, have their own internal data representation, and can take care of themselves. And we'll go a little bit even further with that when we cover encapsulation.